Have you ever watched a marble zoom down a track? It seems like magic, but it is actually science in motion. Let us take a closer look at a simple marble run to see how these invisible forces work together. Think of a slope like a slide. The steeper you make the tilt, the more exciting the ride becomes for our marble. Now, place the marble at the very top. It stays perfectly still until we let go, waiting for a special force. That force is gravity. It is the invisible pull of the earth that keeps our feet firmly on the ground. Gravity acts like a constant engine, pulling the marble downward toward the center of the planet at all times. As soon as we release the marble, gravity takes over. It pulls the marble down the slope, starting its journey. As the marble rolls further down, gravity keeps pulling, causing it to go faster and faster every single moment. This increase in speed is called acceleration. The marble is gaining energy as it moves down the track. Now, let us talk about velocity. Velocity is just a fancy word for speed combined with a specific direction. As the marble rolls along the track, its velocity is constantly changing because it is moving faster and faster. Imagine the marble heading down a straight path. Its velocity points exactly where the track is leading it. If we change the shape of the track, the marble changes its direction, and its velocity changes right along with it. But have you noticed that the marble does not roll forever? Eventually, it slows down and comes to a complete stop. This happens because of a force called friction. Friction is the resistance that occurs when two surfaces rub together. When the marble touches the track, they are constantly rubbing against each other as the marble spins forward. This rubbing creates a tiny amount of friction, which acts like a gentle brake pushing against the marble's motion. Think of friction as a hidden hand trying to slow things down whenever objects slide or roll against each other. The surface of the track matters a lot. If the track is very smooth, there is very little friction to stop it. On a smooth surface, the marble can roll for a long distance because there is nothing to hold it back. But what if we use a rough track, like one covered in felt or sandpaper? The surface becomes much bumpier. Those tiny bumps catch the marble as it rolls. This creates much more friction, acting like a stronger brake. On a rough track, the marble will slow down much faster because friction is working harder to stop it. So, we have a balance. Gravity and the slope work together to give the marble speed and keep it moving. At the same time, friction works against that movement, trying to steal the marble's energy and bring it to rest. It is a constant tug-of-war between the pull of gravity and the resistance provided by friction. You can see this in action by changing your track. Try making the slope steeper to give gravity more power. Or, try changing the material of the track to see how different textures affect how far the marble rolls. Every time you adjust your marble run, you are experimenting with these fundamental laws of physics. Physics is not just in textbooks, it is happening all around us, every single day, in everything that moves. From the way you walk to the way a ball bounces, these same rules of gravity and friction are always present. Next time you see something rolling or sliding, look closely and see if you can spot these forces at work. The world is your laboratory, and there is always something new to discover when you start asking how things work.